I'm going to show you how to replace or hopefully repair your trim limit switch and your trim sensor on an outdrive. What we've got here, this is my 1984 Larson. It's got a 181 cubic inch, also known as the 140 Mercruiser 4-cylinder engine. It's basically just a GM block with the, I think it's an Alpha 1 drive on here. And while I was doing some routine maintenance, I came across some wires that didn't look too good inside the engine compartment. And here's, hopefully you can see this, here's one of them. Basically, the covering of the wire is just brittle, literally falling apart. I had, bare exposed wire in there. So I tracked these down. They turned out to be on my trim switches here. So I thought before I just swap these out and buy new ones, they were still working. I could still trim the engine. I still had a gauge. Everything looked good. Just the wires are falling apart. So I thought I'd take a look, see if they're repairable versus replaceable. As I did that, a little research here. If you follow Mercruiser's recommended way to replacing those things, they're telling you got to remove your outdrive. That's a major project. I mean, you've got to take your cylinders off. You got to take the outdrive off. You got to take all your bellows loose. You're going to pull this gimbal housing off of here just so you can get to 2 bolts where the wires run through. Taking a look, I figured there might be an easier way. So if you have your outdrive and you look up through this side, you'll be able to see those 2 bolts. But they're really hard to get to because they're directly behind here. So there's one bolt up here, there's one down a little bit further. A little ingenuity, I think I found a way to replace those and get to them without having to tear this whole outdrive out. If I can do that, it's going to save a lot of time and a lot of money. I won't have to buy all these gaskets, or I'm guessing I would probably ruin one of the bellows doing it. So I was able to get them off, both of those bolts off, pull them out, and I'm going to show you what that looks like. Alright, here's my trim limit switch and my trim sending unit. They are a little bit different. This one right here, I'll open it up here in a second. Basically what it's going to do, this goes on the left side looking from the rear of the boat, and it controls how far you can raise your lower unit with the hand trim switch. So what's basically on your throttle, and that's just a protection so that you don't pull the lower unit out of the water at high speed, or just pull it out of the water even when you're trailering the boat. You want to make sure that prop stays in the water. So this is going to limit that. You raise it the rest of the way with the other switch you have up on your dash for trailering mode. This unit here, what this is going to do is just really show your gauge. It's going to give you an idea on how far that lower unit is out of the water, or how far it's raised actually. So what I'm going to do, let me open them up and I'll show you what they look like. Here's my trim limit switch. I've opened it up. There's only 4 screws on this cover you take apart. There is a rubber gasket that runs around here, so make sure you don't lose that. Don't be surprised when you open this up if you find water, maybe some mud, depending on where you've been driving your boat. It's going to be pretty dirty. I've already cleaned this one up. Basically, once you take that cover off, you can pop this centerpiece out, and that's all there is to it. You've got this piece here. Make sure you get that all cleaned up, those contacts nice and clean. There's a couple little rubber, they're kind of like O-rings around here. That's supposed to be what's going to keep this sealed. And then you've got your 2 blocks that just basically it's an on-off switch. In my case, I want to rebuild these things. So there's another screw that I'm going to remove here. And then basically what you have, these are kind of like brushes. They just have a wire that come out, and then this wire looks like it's crimped to or soldered to this wire. And using a small screwdriver underneath the lip, I was able to pull this up and take those out. I can run my wires through, and I'm sure I can salvage this unit by replacing that wire. Now, what am I going to use for wire? What looked like, this being the stock wire here, where you've got 2 wires molded together, I went out and I found basically it's lamp cord. Pick it up at your local hardware store. I bought a little 25-foot spool for I think it's $9. It's about the same type of rubber. I think that's really where the problem with these units come from. Mercruiser, if you're watching this video, you need to change this. All the other wires in my boat, they're all 30 years old. None of them are degrading except for this one. And I think it's because of the type of rubber. It's not a siliconized rubber. It gets very hard, brittle, just falls apart. And from what I can read online, people are still complaining about that same problem. So I'm not sure if this lamp cord is really going to last any longer. I think I may even put a heat shrink over this on the outdrive just to give it a little more protection. But if you can find this style of wire, a siliconized or more of a softer rubber, I think you'll get more longevity out of it. This is the trim position sensor. What you got 4 screws in the top, 4 screws that come up through the bottom. There's going to be a gasket and the same center piece that you had in the other unit. And then you've got a couple resistor wires here versus just the solid blocks. If you're going to be cleaning this, I recommend go ahead and take these 4 screws off, pull it out, get it all cleaned up. There was water in this one. It had quite a bit of gunk in there, so I'm going to go ahead and clean that out. The nice thing is on the back, I don't have to solder wires or do anything like I have to do with the other unit. These actually just screw in with 2 wires, so this one's going to be a lot simpler to repair. I think what I'll do is when I do this, I'll put some dielectric grease on here, kind of keep this unit sealed up, probably make a new gasket, and then this will be salvageable. Okay, so the next part, actually the funnest part of this whole thing, is to try to get the wires out of your transom. And what you're going to find is this is the clamp with the bolts that are going to be at the top of that transom. Now this bottom bolt I was able to get into fairly easy using this 3/8 inch drive with a swivel head on there. If you've got a 1/4 inch drive, I think it'll even be easier to get up in there. The top bolt's the one that with the challenge. There wasn't enough room for me to get the swivel in there. So luckily in my toolbox I found this old 7/16 wrench, only half of it left. I was able to heat it up, put a little more angle on it, and then could squeeze my hand up in there, kind of blind, and get on that bolt and get it loosened up and pop that out of there. Once that comes out, you're going to have wires, and there's going to be 2 sets of them. And what they've got is a molded in rubber grommet. Fortunately, the way they molded that, this is salvageable. Get yourself an X-Acto knife, just cut the back, and then work it back and forth, and eventually you're going to be able to peel that off. With what I had to do, I needed to take one of these files, make the holes just slightly larger so that my new wire, which was just a little bit different, could slide through there but still have a tight seal. What I'm going to do is once I get the wire in there, I'm going to put a little silicone around it just to make sure it's sealed up. Okay, here we are inside the build. Just thought I'd give you guys an idea on where these wires connect up. Make sure that you've got a partner when you're going to run those wires through the transom. You're going from the outside to the inside. You're going to need him or her to put a little bit of tension on those wires, hold that grommet in place while you try to put the cap on from the outside. As far as the wires, you've got a trim position sensor. One wire is going to connect to this block here in the back. It's the second wire down on the right. And the other wire is going to connect on a block here on the engine. Get in there. It is the screw on the bottom it's going to connect to. And I think that's just it's not a grounding block. I think it's just it's plastic, so I think it's just a connection. Then you got your trim position, or your trim limit switch, I'm sorry. That's going to be back here in your tilt and trim motor. And there's 2 wires there. They are bullet connectors. Connect them up, and again, it does not matter which way you plug in the wires on either switch, because one is just reading on off, the other one is reading resistance, so it shouldn't matter. I mentioned earlier in the video that I was going to put a little dielectric grease inside those switches. It's fine on the trim limit switch, but the trim position switch, it's actually a wire wound resistor. So by putting that in there, I was getting not as low a resistance as I needed. The manual says between 0 ohms and 160 ohms should be the full sweep. I could only get down to about 30, so it was causing my gauge to read about halfway up, and obviously I didn't want that. So I got some electrical cleaner, cleaned it out, and then I used basically a pencil eraser and clean those wires very carefully. Again, they're really small wires, you don't want to mess them up. So just go with the wire and kind of polish them up. After I did that, I was able to get my resistance down to about 9. So my gauge is very close to the bottom and it's livable. Okay, so the next part is we're going to show you what we did to get that cap, basically the hardest part of this install, done. Okay, so I got it all back together. Everything's working. Trim position sensor's working. Trim limit switch is working. Well, let me show you where the challenge is. I'll get my light up in here. You can see right there is that cap with the lower and upper bolt that you've got to get tightened up. That's the one you're going to spend hours possibly trying to do. Actually, it's not that bad if you, like I say, if you can get small hands. This bolt here, the closest one, you can get in there with a wobble. 1/4 inch probably works the best. I use 3/8. I was still able to get it. But that top one, that's the bear. You've actually got to go in from the other side blind and try to, you can actually get it out pretty easy with the wobble, but putting it back in, you've got to get it started by hand, and it's a lot of hit and miss. So my concern is whether or not I got it tight enough. I'm going to show you the tools that I used, and one that I just picked up that I'm going to try. I'm not sure whether it's going to do it or not, but these are the tools that I ended up using. This is my wobble, 7/16 wobble on the end of a 3/8 drive. You know, the shorter diameter that you can get here, the better. So I think you could save a little bit of room with a 1/4 inch. And this is kind of the tool I just fabricated on the fly. I had this old 7/16 inch wrench, really thin. Took it, heated it up, gave it a little more angle so I could reach in there, and just taped it on the end of a really long screwdriver, and that was able to get me in there. This is what I thought might help. You know, unfortunately it doesn't have a long enough handle, so I'll probably still have to use the trick with the screwdriver here. But I'm hoping I can get this one in on the top. It's got a really tight you know, movement on it, so that was my problem with the wrench, is I couldn't get it indexed right. I'd get it tight, and then it wasn't enough to go to the next thread. So this possibly could fit in there. I'm only concerned about, you know, the diameter. I think it's going to be tough, but I'm going to give it a shot anyway. If I do, I'll just, you know, put a note out there in the video and tell you whether or not it worked. But also a good book to pick up. I've had this one for years. Pretty much explains everything about this engine combination motor, the lower unit that I have. So hopefully this will help you. I guess what I proved is it is possible to replace the limit switch and position switch without having to take the lower unit off. So I think that saved me a lot of time and you know, probably some other parts that I'd had to buy. My point is to Mercruiser is I don't know what their engineers were thinking. I mean, this is a perfect example of people that design stuff that don't actually use stuff. And the reason I say that is if you take a look at where these switches are and you look behind there, there's this huge area. There's nothing that goes through the transom. They could have put a hole on each side with that same setup, you know, for a grommet, and this would have been a 15-minute swap. So if anybody from Mercruiser is listening, you failed miserably on this one. You could have done this so much easier, and there'd probably be a lot more people that would actually replace these instead of running without them. So, you know, again, hopefully this helps you guys out, and if you got any questions, let me know.